Oh, Xavier, quick question for you.
Yes. Yeah, shoot.
Why are you Foz and why is Matt one pot?
I'm FOSS because I'm old. It's short for fossil. Um, I'm by far the oldest in the research group. Well, not by far. I'm only a year older than Kyle. Um, and Matt is one pot because he had a reputation at the start of his research for doing all of his reactions in one reaction vessel.
I
Um,
thought that might be it.
Yeah, so instead of like you'll do in the next brack, actually, you make the ligand first and then you add the metal. So typically, what we'll do in our research is we'll make a ligand and we'll isolate it and like characterize it and make it in bulk, and then we'll take a little bit of that ligand and we'll put it in the metal solution and make a complex, hopefully. But Matt had a reputation for just making the ligand and putting the metal straight in there and doing it all in one pot. So.
Cool.
Hence the name, and not the only chemist that I've met with that nickname. Actually, we ran into another guy from ANU in Canberra when we were down in Melbourne at the synchrotron, and he also had the same nickname. So not uncommon.
Very cool.
Yeah, good question though. Brian, yeah, I won't tell you exactly, but I'm a touch over 30, close enough to 30, close enough. Okay, so
Considered old?
sorry.
What is this, tennis? That's considered old? What is this, tennis?
I think in the context of quite a young research group, I was definitely an outlier. Although, like I said, I'm not that much older than Kyle. Maybe I just act older. But that's fine. Isabella, I'm going to mute you just because I don't think you muted yourself. Okay, so we've got 20 people back. I think that was about what we had before. Sorry about that, guys. I don't know why that's happening, but thank you for rejoining. And as I said, we'll just quickly have a closer look here. Okay, so as we looked at before, we need to find, and I'm just going to edit the slides. That's probably the easiest way to do it. We've got to find the reductant for step one. Um, And if we have a look at our possible reagents, so as we said, the reductant is going to be oxidized, right? It's a reducing agent. It's going to be oxidized. So, and that's the result of a redox reaction. And oxidation, we can look at it as an increase in the number of oxygen bonds. Okay, so if we look at our possible starting materials, H2O, not very likely to increase the number of oxygen bonds. H2SO4, also we're probably not going to end up with double bonded sulfur oxygen happening. So that leaves us with the ethanol, which if we write that empirically, CH3, CH2OH, and we can see that we could quite easily lose a proton here. So it ends up CH3CHO. So we've actually lost two protons and we've ended up with a aldehyde product. So for those of you who've stuck around right to the end, that's the most likely reductant there, the most likely reducing agent, going from the alcohol to the aldehyde, an increase in bonds, oxygen bonds. So now that you know that, that should help you a long way to working out what the vanadium 4 compound is going to be. I hope. So that the first step in that in finding out the balanced equation to that reduction reaction is finding out the reductant, and well, there it is. I've given it to you. So hopefully that helps you. But if you are really struggling with it, the literature should help a lot, both the sources that we've provided in the lab manual plus when you go out and look for yourself at the various resources, should help you figure out what your vanadium-4 compound could be. So hopefully that's helped everyone a little bit. Has anyone else got any other questions about the Prac itself or the report writing or what's required from the report? I had a question in this morning's session about the length of the report, and my answer to them and what I'd say to you guys as well, don't worry so much about the length. Like, don't be too concerned about the word count. We haven't actually specified one. Just make sure you go through and follow the formatting, use all those headings, and put in what you need to put in following the marking guide. And the word count will kind of take care of itself. I'd say as a ballpark, aim for like a page and a half or something. You know, it could be, I'd say aim for roughly 1,000 words, but don't be too concerned about it. But don't make it just a couple of paragraphs. It is a full report. And please don't make it 10 pages because I have to mark 80 or 90 of them and that'll take me forever. So don't make them too long. So that's a rough guide on the length of the report. We've been through referencing. Yeah, if there's any other questions, let me know. Patrick, the O bond becomes a double bond in the aldehyde. Yeah, so you go from a single bond between this carbon and this oxygen. So that's a single bond. And you end up having a double bond between the carbon and the oxygen in the aldehyde. Should it be written by hand? No. So as we talked about just earlier, it should be typed. It's a formal report, and it's it's a formal assignment submission. So please type it up. Best way to submit it is in PDF format if it's possible. If not, just in a Word document. But yeah, it should definitely be typed. Okay, no worries.
Do we include a risk assessment?
That's a good question.
Because I can't see it in the marking criteria.
Yeah, it doesn't say it in the marking criteria. No, I don't think you need to. It's not in the marking criteria, so don't worry about it. Yeah, no, don't worry about it. That's fine.
Okay, thank you.
All good. How much percentage is it worth? It's worth 10%. So overall, your practical component's worth 30% overall, and this is 10%. The other 20% comes from the result sheets and lab books for the other pracs. Okay, any other questions? It's 3 minutes to 2. So if there's no other questions or nothing that we need to go back over, we can probably end it there. Everyone's happy with that. And Brian, I'll just hang around and talk to you for a little bit after we're done.
Yeah.
Okay, cool. If that's it, I'm going to stop the recording.